Hello students, today we are going to learn about momentum in two dimension. This is the topic of module 3.5. We have done momentum, linear momentum, momentum in one direction and impulse, and this is the third lesson about momentum when we talk about in two dimensions. Have a look for this question. What would the velocity of the white ball be after the collision? And if you consider both balls have same masses and that speed are in meter per second. Right, well done. If you got like white ball, we'll get 2 meter per second speed because according to law of conservation of momentum, the momentum remained conserved before collision and after collision. It remains same. This is a little bit harder. How would you tackle this? What extra information would we need to know? Now the black ball is moving in some direction, and this is to find out this, we have to find out its x component and y component. So this is called the momentum in two dimensions. So when we have done the projectile motion, if you could remember, so when we find out the velocity in the projectile motion, we consider its horizontal and vertical component. So same here we will do, but remember that horizontal and vertical motions are independent of each other. So similarly, in momentum, the horizontal and vertical components are totally independent of each other. They are both conserved. So you can see in this example, when we will talk about the two-dimensional momentum, we have to consider the momentum before collision and momentum after collision in two directions. So first we will find out the momentum before and after in horizontal direction, and second we will find out the momentum before and after in vertical direction along y-axis. So when we do two-dimensional conservation of momentum, we must remember that momentum is conserved in all directions. This is the practical example of momentum. You can see in the snooker balls, and we can see in the bowling games when some collision happen and the balls move in certain directions, in different directions. So if we are particularly find out the velocity of one ball, so we have to consider its x and y component both. So while analyzing two-dimensional momentum, you have to consider the vector component and angle. So if I talk about the momentum of this whale, so if it is moving in this direction, to calculate its speed and momentum, we have to consider its x component and the y component. So either we are getting the speed, the velocity, or we are getting the momentum. So we have to consider its x component and y component, and we have to consider the angles between this. So here is an example. You can see a white ball and a black ball. So white ball has a speed of 4 meters per second, and it hits a black ball which is stationary initially and has no speed. After collision, a black ball moves upward with speed 2 meters per second, velocity 2 meters per second, and angle 45 degree along x-axis. And the white ball moves downward, and we don't know the speed. We have to find out the speed and velocity of the white ball, and we have to find out the angle as well. So this is the example of two-dimensional momentum. This is a simple problem. So before solving the problem, two-dimensional problem, a good approach usually follows a general procedure. You have to follow these steps. Number one, you have to identify all the bodies in the system. Assign clear symbol to each and draw the simple diagram if necessary. You can say like white ball, you can say this is mass 1, velocity 1, and the black ball you can say mass 2, velocity 2, or you can make it color coded, or you can make it mass coded. It's up to you, but you should know that identification. Second step is you should write down all the values you know and decide exactly what you need to find out to solve the problem, like we do in given data, what we already know and what we have to find out. Number 3, select a coordinate system, which is x-axis and y-axis. Next is you have to write down the equation which equates the momentum of the system before collision and after the collision. Number 5, you have to solve the resulting equation to determine an expression for the variables you need. This is a little rearranging of equation, little mathematics is involved here. And lastly, substitute in the number you know to find out the final value. So these are some general steps you have to follow. Let's do this example. That's a very basic question, basic examples. In this example, first of all, you have to look carefully what you are given, what you have to find out. You have two balls. First, you have to find out what happened, what was the momentum before collision, and what was the momentum after collision. As you see, initially, before collision, there is only one dimension. There is no two-dimensional movement. But after collision, there is a two-dimensional movement. So we have to find out the horizontal and vertical component respectively. So first of all, you identify like white ball is M1 and black ball is M2. And the velocity and speed is for white ball is U1 is initial speed, V1 is final speed, or you can say U1 is the speed before collision, V1 is the speed after collision. So this is a simpler example. So I consider if all masses are same. So all masses will be cancelled out and we will get this equation. U1 plus U2 equals V1 plus V2. Like speed before, velocity before collision equals to velocity after collision because all masses are same. This is a particular case. Now substitute the values. So U1 initial speed for white ball was 4 meters per second. And as I said, black ball was stationary. That's why its speed is 0. You have to find out the speed of the white ball. So first of all, because we are doing horizontally, we will find out the horizontal component, which is V1x. And V2x is 2 meters per second, but its x component will be 2 cos 45. If you recall your component knowledge, we take the cos as for x component and sine for y component. By rearranging it, you will find out your x component, which is 2.5857. Same you will do for your vertical component, the same equation. As I said, all masses are same, so masses will be cancelled out. You will get this equation. And you can see, before collision, there was no vertical component for white ball and black ball. So we will say y component is 0 for both of them. And V1 is 2 sine, V2 is 2 sine 45 and V1y we have to find out. By rearranging it, you will get this your answer V1y. Now we have the x component of V1, white ball velocity. We have the y component of the white ball velocity. Now by using Pythagoras theorem, we will resolve it. Here you go. When you do a little calculation, maths involved, we are very familiar with the Pythagoras theorem, and when you do that, you will get this answer. So you can round this up, and you can say 3 meters per second, your velocity of 2.947 meters per second. By using tangent theta equals opposite over adjacent equation, you can find out the angle. So this is your answer, that white ball is moving with 2.947 meters per second velocity in the direction of 28.67 degrees. Okay, so that was a simple question, and there are some rules for this. So if this is some general easy rules, if the ball is moving from left to right, we will take this movement as a positive. But if the movement of the ball is from right to left, we will take this movement as a negative. As I told you that momentum is a vector quantity, so direction is very important. Similarly, if the ball is moving from bottom to top, you will take this as a positive. And if it is moving from top to bottom, you will take this movement as a negative direction. Okay, another example. So a 2 kilogram puck sliding in the x direction on a frictionless horizontal surface at 5 meters per second strikes a 3 kilogram puck. After the collision, the 2 kilogram puck is observed sliding at the velocity of 2 meters per second, directed 60 degrees to the right of the x direction. And what is the speed and direction of the 3 kg puck? Now, here is a little bit direction of my drawing is get messy a little bit, but now the masses are not same. These two pucks have different masses. One is 2 kg and the other is 3 kg. So again, the first step, you should identify what you are going to take it here. So which one is your M1, which is your M2, which is your M3, or you can take it according to their masses. Right, let's start doing this. First of all, let's find out the x and y component of the velocity of the 2 kilogram puck after the collision. So you can see, if I talk about the x component, so v2x equals to v cos of theta, which is 2 cos 60, and I got 1 meter per second. This is the velocity of the 2 kilogram puck after the collision. So that's why I'm taking v. And here the y component is 2 sine 60 degree, and this is the speed after the collision. So anyway, easier for you, you can do it. Right. So when you look carefully, you see that this component is in the negative y direction because this is moving from left to right. Okay, now let's use the momentum in the x direction. Again, I said you can start from the equation, identify m1, m2. Why I have taken m2 and 3? Because according to their masses. So m2, v2 is the mass and velocity of the puck. m3, v3 is the mass of the mass and velocity of the puck having mass 3 kg. Now you can see by putting the values in it, I got the x component of v3, 3 because I'm calculating the velocity of the 3 kg puck. So this is my x component, and use a little maths. You can see the velocity is minus because this was moving from the other direction, moving up towards. So you can calculate the x and y component accordingly, and then you can use Pythagoras Theorem to find out the speed for 3 kg puck by using this calculation. So your velocity of the 3 kg puck is 2.91 meter per second. And by using tangent theta, you can check what was the degree, what was the angle from the x-axis. So this is 23.4 degrees from the x-axis. So that's your answer. And this will be including in our next lesson about kinetic energy. So elastic and inelastic collision. So if you analyze the kinetic energy of the two pucks before and after collision, you will find out this is not a perfectly elastic collision as some energy is lost. So this makes no difference in the momentum. So this calculation we will include in the next lesson when we will talk about the elastic and inelastic collision. This is another example. Same, a white ball of mass 50 grams traveling in 3 meters per second in a straight line at an angle of 50 degrees. Now you can see initially before collision it has some x and y component, and the red ball it collides with a red stationary ball. So red ball was stationary and at the speed of 2 meters per second in the direction of the shown below. Now you have to calculate the final speed of the red ball. You can see the white ball is moving up towards upward, but from right to left. So you will take that speed in the negative direction. And remember, you will follow the same step what we have done in previous two examples. And these link provided on the top of YouTube link will take you to the solution of this question. But before looking into the YouTube link, I want you to solve this question first and find out your answer. You can pause the video, do your calculation, and then go to the link to calculate to check your answer. Here is another example. A 3.7 kg steel ball traveling at 4.5 meters per second due east collides obliquely with an 8.4 kg aluminium ball initially at rest. So you can see here again, initially before collision, there is no vertical component of the movement. So you can take it easily step, and the big ball has no velocity, initial velocity. So masses are not same as well again. So following on the same steps, you will be able to calculate the velocity of the aluminium ball. So pause this video and do your calculation first. Brilliant. If you get the right answer. So the answer is 1.5 meter per second, and the angle is 13 degrees from north of east. So if you get the correct answer, well done for that. If not, you can try again. Next, this is another example. So you can pause the video, do your calculations, and find out your answer. Well done if you got the right answer. All of these questions I have done, I have solved. There is no problem in calculation. You can do this easily. This exam question I will attach on Show My Homework separately. This question involves some more other calculation. This question involves some equation of motion, some momentum equations, and some logical questions. So this is your homework, and answers are in the next slide as well. So you can print this question from the Show My Homework, and then you can pause this video, do your question, and once you finish, then you can match your answer with that. You can see in this part, we have used the third equation of motion to calculate the initial speed, because we were given the acceleration, we were given the initial speed. We were given that the final speed was 0. In this step, we can see we can use simple basic equation of the momentum, because we were given the speed and we were given the mass in the table. In this question, you can see we have to find out the component of the momentum. So here you have to find out the component of the momentum. The data is given, the magnitude of the momentum was given to you. You just need to find out its component. In this part, you have to find out the conclusion speed. And here's the logical explanation of how investigator could use conservation law. So you can say it was a momentum conservation, or you can see that. So well done if you got all answers correct. So make your practice. I have attached some notes along Show My Homework, and I have given you some exam questions as well. So do your practice, and well done for your working hard.